y equals 3 cotangent of pi over 2x plus 1. And the first thing I want to stress on this one, like I stressed on number 9, is that the period when we're graphing cotangent, the period when we're graphing tangent is pi, not 2 pi. So as I go in order this time to graph this function, when we take a look at this, to figure out the period, we're going to take pi divided by pi over 2. And once again, when dividing, don't multiply. Flip the second one and multiply. So we get 2 pi divided by pi. And our period's going to be 2 on this. And when we fill that in, 1, 2, 3, 4, there's 2. So half of that is 1, and I'll have to write that again. Vertical displacement, well, we have a plus 1, which means that we're going to be up 1. Reflection, we do not have any reflection. When we get to our domain, once again, we can get it set up for all real numbers such that x doesn't equal something n, where n is, and then we need to fill it in. And the nice thing is on our range here for cotangent, we're going to have all real numbers, negative infinity to positive infinity. So we've got a little bit of this situated for us. Let's go ahead and put in our vertical displacement here at up 1. So there's that. And actually, we're not going to phase shift, so we can start there as well. And the thing about this one is, again, and what you might want to do is go back and look at your tangent notes, because you want to look at the pattern for the cotangent function. And if you remember, what we said is that the cotangent of 0 is undefined. And then the cotangent of pi over 4 is 1. And the cotangent of pi over 2 is 0. And so forth. And what that ended up to look like is that we had an asymptote here. Here's our 0 on our function. And then we did the cotangent of pi over 4, we said was 1. So I'm going 1 above that highlighted line. And then we said that the cotangent of pi over 2 was 0. And then we did the cotangent of 3 pi over 4, which was negative 1, which was 1 underneath that value. And then when we finished, we came up with the cotangent of pi, but the cotangent of pi was undefined. So here is our cotangent graph with a little disorientation in there. But we can get another 1, 2, 3, 4 that we're going to put in another asymptote. And I want to stress to you to go back and look at the first 2 graphs that we did on the tangent and cotangent notes, because look at the pattern of them. Get those in your head to study for a test or a quiz. But once we get 1, we can get them off. We can keep going. 1, 2, 3, 4. And we copy the pattern. So there's 4 periods actually of our function. And the last thing that we need to do, and we'll look at it a little bit more specifically, but notice that our first positive asymptote is at 2. So it has to be the first positive asymptote, not the one that's on the y-axis. And then as we look at this, so we've got 1, 2, here's 3, and then this one is 4, so over here is 4. When we look at this again, this is 2 times 1. And then our next asymptote is at 2 times 2. And we're looking at those specific values of 1 and 2, and what we end up with here is that where n is an integer. Just a couple things that I want to stress here as you finish the packet, and that is, go back if you haven't done your tangent and cotangent practice. Go back and make sure that you do those practice problems, and remember that the period for cotangent and tangent is pi, not 2 pi like the other functions. The period of sine is 2 pi. The period of cosine is 2 pi. The period of cosecant is 2 pi. The period of secant is 2 pi. Go back and rewatch any of these videos and practice, practice, practice to get ready for your test.